Good evening, everyone. My name is Mugombia Benon, and I'm going to be presenting my project, my AI project that's a car prediction, a car price prediction model. And I'm a student of Makerere University doing computer science. Yes, and I'm in Uganda. So today, I'm going to take you through what I'm going to basically discuss in this presentation. We have the introduction, we have the problem statement. We are going to talk about the different data sets we employed, the factors we considered when choosing our database, our data sets, our data set features. We're going to talk about in detail the Bayesian theory, the naive Bayes, the Bayesian networks, the difference between Bayesian theory and the naive Bayes, and also the difference between naive Bayes and the Bayesian networks. So to start, I'm going to introduce our presentation today by basically talking about what AI is, because we are going to be talking about AI more in general. So today, artificial intelligence, which many people call AI, is a crucial part of our life. Different models of artificial intelligence are employed with the goal of simplifying our life. AI is basically evolving to simplify our life. Artificial intelligence in itself is basically having computers think more logically or in an intelligent way. Some want to call it in a way like humans think, but here it's in a smaller portion, and depending on our problem is how we describe what our AI model should do. So in this presentation, we are going to basically study a problem, build a model, and analyze our model. So to begin with, for us to have a solution, 3 are supposed to have a problem, and hence we have a problem statement, basically what we want to solve. So our problem statement is to improve car sales today through sales maximization. So basically what we want to do is to improve our car sales. And in order to do that, we want to set variable prices that enable the seller make a profit and also be relatively cheap to the customer, because it should be a win-win situation for both of them. The seller should set a price that is optimal for them, and the buyer should also benefit from a price, should get a price that they are willing to offer or to pay for. So we're going to use a data set, and this is my data set link. Our data set has data that has very many attributes, and most of these attributes are going to use them in our price prediction. So basically our data set has very many attributes like the car model name, the fuel type, the car height, engine type, the engine size, all these different things that come into play for the final price of a car to be set. So before that, I considered very many factors to come to a conclusion, take this data set. Of course, I already told you where I got my data from, and I've shared the link, and also share the link in the description for the data set. I considered basically four factors for me to take on this data set. First factor to consider choosing a data set is the quality of the data set. Quality basically you're talking about is how reliable this data is, how reliable data is considering factors like, did they obtain it the right way? Is it complete? Does it have all the necessary data we need? Because quality of data is relative to the project. If the data has the attributes that you need, then you can maybe say that your data has a quality that you need. And then we need a sufficient quantity of a data set, because we need our data set to be over of a large size, or let me say of a good size, a size that is large enough that can increase our chances of making a prediction. Because a large data set size enables our model to learn more efficiently and we would hope to get more accurate results. Then their relevancy. We want to use a data set that has relevant data. For instance, if we're talking about car price prediction, that data set should have things more relating to cars. We can't have a data set having things talking about celebrities, makeup, and all. That's not relevant to our AI model. So the data set should be relevant to the problem or to your project. Then the data set should also be variable. Variability usually helps us to avoid things like bias in our data. So should be taken from different regions to prevent bias within our data. So for our data set that we chose, our data set had very many features, and we have the car name, the fuel type, the car height, the horsepower, and the engine size. So I'm going to talk more in detail about our features of this data set. The car name is relevant in this way that some car name brands command a higher price. Like let me say a Lamborghini, which is as small as a Corona, commands a higher price because Lamborghini has a brand name that is weightier than the Corona. Then we have the fuel type. Research has showed that diesel engine cars are usually more expensive than petrol cars, according to research. And this is a good factor for our AI model to consider in its learning process, that diesel cars tend to be more expensive than petrol cars. Then the car height. Now the car height helps us determine the size of the car. Of course, a car with a large height may mean that the car is actually big. And of course, bigger cars tend to command higher prices than smaller cars. Then the horsepower. The horsepower is, like we know, horsepower is basically, like, many people want to call it the strength of a car or the versatility of a car, but we know that cars with higher horsepower, like let me say the racing cars, usually have higher car prices, because a higher horsepower usually means, let me say, in this sense, you could say the car is, let me say, stronger, so it would command a higher price. Then the engine size. Of course, a large engine size would usually dictate higher prices, because the car is I want to avoid the word strong, but in this sense, the car is, let me say, has a higher horsepower because of the engine size. So, and of course, because of the more mechanics involved in the development of the car, the large engine size will eventually lead to more costs on building the car, which in turn leads to a higher cost for the sale of the car. So you need your AI model to consider all these factors in learning on how to predict the price. Of course, these are some of the few attributes or features within my data set. So now I want to talk about an important concept called the Bayesian theory. Now, the Bayesian theory or Bayes theory is just a mathematical formula that calculates the conditional probability of an event based on the values of specific related probabilities. Basically, Bayes' theory states that the conditional probability of an event based on the occurrence of another event is equal to the likelihood of the second event given the first, multiplied by probability of the first event. Basically, what Bayes' theory is all about is a mathematical theorem that helps us get the conditional probability of, let me say, a certain pair of data from, like, let me say you want to get conditional probability of data, but you have only a bit of the data and you don't know, like, most of the other data, the other probabilities relating to those different fields. So Bayes theory helps us use a method of generating the probability using other known facts about the probability to generate this condition probability that is in question. So we want to talk about naive Bayes. Now, naive Bayes just basically borrow from Bayes theory. Or in this case, naive Bayes implement Bayes theory in machine learning. So naive Bayes is a classifier in an algorithm that uses Bayes theory to classify objects. Naive Bayes classifiers assume strong or naive independence between attributes of data points. So what basically that means is that when you're using the naive Bayes, the attributes we applying the Bayes theory are assumed to be independent, because in our machine learning thing, especially and in supervised learning, we usually use independent attributes to determine our dependent output that we want our machine to learn from. So the naive Bayes are usually used in spam filters, text analysis, and medical diagnosis. So naive Bayes can also be called independency based, because remember, we consider independency of the different attributes or the different features that we are using within the process of machine learning. There's another important concept that we need to know, which is the Bayesian networks. Now, the Bayesian networks are just a representation of our data, are a representation of Bayes theory, but in a more graphical manner. So a Bayesian network is a compact, flexible, and interpretable representation of a joint probability distribution. It is a useful tool in knowledge discovery as the so typically our Bayesian network, for example, here we have here we have our dependent variables. We have season, independent features. You have season, rain, one. Now those are called nodes. Then the arrows, like let me say the arrow from season to rain shows that the season depends on the rain. So the arrow usually show the dependence of show us which variable is dependent on the other. Because the circles indicate the feature, then the arrows indicate that dependency, which one is dependent on the other. Here, our season, like allergies are dependent on the season. Yeah, usually people get allergies depending on the season. Then of course, umbrellas are dependent on the season. Umbrellas are dependent on the season. The rain, I don't know if see if I could annotate here. So like I was saying, our season here, our season here is it has very many things that depend on that. So let me say if the season is cold, some people may get allergies. Or umbrellas also depend on the season, because when it's raining, people need umbrellas. Then the season can also determine if you're expecting rain or no rain. So basically, the networks show us the circle, like let me say atmospheric pressure represents the feature. Then the arrow here represents shows us the dependence of this attribute to the other. Yeah, so let's move on. So now we want to differentiate. There could be a confusion between the Bayesian theorem and the naive Bayes. So The Bayesian theory is just a simple mathematical formula, and our naive Bayes depend on that. So basically, the Bayesian theory is a mathematical formula that our naive Bayes follow. Here, if I'm to take you through our presentation, they are completely different things. Naive Bayes is a type of prediction model, a prediction model in AI, one which assumes that all of the features are mutually independent. Like I said, it assumes that all the features you consider are independent. Then Bayes theory is just a mathematical formula that allows us to infer the probability of a particular model given observed data. So naive Bayes depend on Bayesian theory because a naive Bayes, it's just an AI prediction model within our sklearn toolkit, but depends on Bayes theory. And here we can see Bayes theory formula that we can use here in case you want to get the probability of A given a condition of B. We can use the probability of B if it's known given A times the probability of A out of the total probability of B. Basically, that's the formula of Bayes theory. So we also want to explore the difference between the naive Bayes and the Bayesian networks. Like we say, the Bayesian network is just a graphical representation. Then the naive Bayes it's a predictive model within AI. So a Bayesian network, there's a reference to it on Wikipedia just to know more about are just relationships between features in a very general way. If you know what the relationships are, who have enough data to derive them, then it may be appropriate to use a Bayesian network. Remember, our network is a graphical representation that just shows the relationship or the dependency of one feature to the other. Then a naive Bayes classifies a simple model that describes a particular class of Bayesian network where all features are class conditionally independent. The features are independent, like I've been saying about the naive Bayes. Because of this, there are certain problems that naive Bayes cannot solve. However, its simplicity also makes it easier to apply and requires less data to get a good result in many cases. So naive Bayes is a probability, like I've said, based on probability and the theorizing of Bayesian theory. Here, which is usually preferred within our model, but the basic difference between these two is that the naive Bayes is a predictive model, whereas the Bayesian network is a graphical representation. So the conclusions are for us, all the takeaways from our discussion is that our model will be assessed and implemented using other theories other than Bayes theory. Though in this presentation, just wanted to exhaustively talk about Bayes theory, the naive Bayes and Bayesian networks for better understanding of our model, as we move and continue within this course. And the later videos to come, we'll be discussing more and more concepts that we are going to be applying for our project, which is going to remain the car prediction model. Below are some references that I made while making this presentation that you can check out for more information. The first link is a link to the data set. You can check it out and check out the attributes of the data set and make reference to it. Thank you very much.